All right, so in the last lesson, you learned how to do something called completing the square, which is a second way of solving a quadratic equation other than the one that you know right now, which is factoring and sometimes graphing. So what we're going to do today is we're going to learn how to complete the square when your leading coefficient is not a 1. So I have 3 examples here. I'm going to write the steps of completing the square that we completed in the last lesson so that we have them here as a reference. But I'm noticing that in these 3 examples, I have coefficients that are not a 1. So what do I do? Can I just follow the steps? The answer is sort of. You have to do quite a few things before you do that. But the most important thing here is you have to make your leading coefficient a 1. And what I mean by that is you have to make the number that is next to the squared variable a 1. Is there a GCF? If not, could there be a GCF? I think that is the big question when we look at this. So when we are doing something like this, what we want to do is we want to just look at the first 2 terms. And by that I mean A and B. Is there a GCF between those 2 coefficients? So let's look at this first example here. I notice that I can pull out the 3 as my GCF. So if there is that, then go ahead and factor out the GCF from A and B only. We're not touching C right now. When I do that, I'm going to have 3 on the outside, and then that leaves me with x squared plus 4x minus 8. Notice I put that trinomial x squared plus 4x, which is a binomial right now, in a parentheses, and I'm leaving some space behind because it's going to become a trinomial. Then I can just go ahead and complete the square. I'm going to divide b, which is 4 by 2. I get a 2, square it. I get 2 squared, that's a 4. And then what I want to do is I want to add the square. And that's why I left that space there. So now I have a trinomial that is a perfect square, so I can just square it out. However, in order to keep this expression balanced and equal to the original expression, I have to do something else. I'm going to multiply my square, in this case the 4, times the GCF that I factored out. That's going to give me a 12. And then I'm going to subtract the 12. And all this happens outside of the parentheses. The reason I'm subtracting it is so that I can keep the equation balanced. But for right now, let's just worry about the steps. After I do that, I'm going to go ahead and simplify. I simplify that by factoring and combining my numbers that are outside the parentheses. And my final answer there is 3 times x plus 2 squared minus 20. Especially in the beginning, you always want to check your work to make sure that what you're doing is correct. Now I can go ahead and check my work and say that this new expression should be the same and give me the same answer as my original expression that I started with. So that's what I'm going to do. I'm going to go ahead and factor out. So I'm going to take that binomial square and make it a trinomial, and then I'm going to distribute that 3 in that trinomial, combine my like terms, and what you'll notice is that I end up with the exact same expression that I started with. So there you have proof that they are equivalent. The main idea here, let's focus on following the steps and that you understand what these steps mean for every single problem. So I'm going to do another problem here, number 3. I love this one because it has fractions, so I know you're all intimidated by fractions. Step 1, I'm going to look at my terms A and B. Is there a GCF I can factor out? Well, if I factor out 1/2, then my A is going to be a 1, and that's what I want. So even though if you don't see it like immediately, you can factor out something. When I do that, I'm going to end up with y squared plus 6y. Leave some space in there so I can add the last term that's going to come up later. And I'm going to leave the negative 4 as it is. I'm going to square my quotient. So I'm going to square 6 divided by 2. And that's going to be a 9. So now I'm going to rewrite it. It's 1/2 times my trinomial is y squared plus 6y plus 9 minus 4. Now I'm going to multiply that 9 times the coefficient that I factored out, which is a 1/2. So that's going to give me 9/2. Please, please, please leave things as fractions. Might be harder for you, but it'll be easier in the long run. And then what I do now is I just go ahead and simplify. Now to do that, I have to get a common denominator between the 1 and the 2 because -4 has a 1 as a denominator and 9 has a 2 as a denominator. So I have to convert that 4 into something with a 2 in a denominator, which gives me 8/2. So when I combine that with my 9/2, I'm going to get -17/2. So this is what I have right now. I kind of ran out of space, so I'm going to move the operation over here, up here. Just going to simplify this, and then I'm going to go straight into checking my work. I'm going to expand that square binomial. Checking work is always tedious and a lot of work, but we have to do it. Let's start by distributing that 1/2. By keeping numbers as fractions, it actually makes it easier when we're doing this step. So I'm able to easily, even though I'm multiplying that everything by a half, 6 goes into 2 3 times. I'm able to easily divide just by looking at things. Now I am still going to have that -17/2 at the end, but they have the same denominator as the 9/2. So I'm going to actually combine that into 8/2, which gives me a -4. And that is exactly what I started with. So this is correct.